Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. So today we are going to understand about the GitOps. Yeah, it's not a Git, it's not a GitHub, it's GitOps. Okay, so that is something which we are going to understand now. So there is a two keywords if you look at this, Git, which you know, the previous sessions we had about a Git itself, so that we understand. And there is a ops keyword. This is something which you also understand. We've been working in operations all the time. I've been discussing about DevOps, SRE, DevSecOps, IT Ops, Cloud Ops, so many things which is happening nowadays. ML Ops, AI Ops, right? So now we are discussing about the GitOps. What is GitOps? So as part of this discussion, we will understand what is GitOps, what are the need for GitOps, what are the benefit of GitOps, what is the difference between GitOps and DevOps, also understand the difference between GitOps and IAC, infrastructure as a code, and some of the GitOps principle and practices. So this is something which will get into that. So understanding what GitOps is. So if you look at the GitOps, GitOps is an operating model pattern for cloud native applications. So operating model pattern for what? CNCF based application, cloud native application. Now guys, those who have no understanding on the cloud native, I think you should have a little bit of offline study. Uh, so cloud native is one of the kind of new initiative which has come where we are trying to develop a set of applications which can manage the large infrastructure in a distributed environment with a higher availability inbuilt, scalability inbuilt, automated observability, open tracing, and many things. So there's one foundation which is called it at CNCF. It is similar to Apache Foundation actually. So Apache, if you know that, they've been managing the thousands of open source product, right? So same way, CNCF is one of the organization which on manage lots of product. One of the very popular products they manage is like a Kubernetes. Apart from that, Prometheus, etcd, and many other hundreds of products. The website which I must show you. So this is CNCF and here Cloud Native for Computing Foundations. Look at this. And you should click on this one. And though they have so many projects, but graduated one something which you should focus. And these are their product lines, right? So this is one of the initiative which govern the software development governance for the new age applications. So yeah, GitOps is an operating model pattern for cloud native application and Kubernetes storing applications and declarative infrastructure code in Git. Understand that. So here Kubernetes cloud native application and Kubernetes storing application. That means any applications which is used Kubernetes for running and which is required declarative uh, way to deploy the code. So declarative infrastructure code in Git as the source of truth used for automated continuous delivery. So continuous delivery, if you remember that I discussed about the DevOps, continuous delivery means deployment to the production. That is something which we have. Here automated continuous delivery means deploy to the production directly. But from where? So here from the code. The code which you modify in the Git, it should lead to the deployment to the production. Simple, understand this. So GitOps in a simple way, if you say you are keeping a code in a Git, which code that we'll discuss, it can be Helm chart, it can be Terraform code, many different types of code. So the moment you write a code in, you commit in the code in a Git, automatically it lead to the production deployment CD in Kubernetes. That is this concept, this operating model, this pattern, this specification is called GitOps. Okay, so GitOps is a fast growing operating model pattern for cloud native application commonly associated with Kubernetes. GitOps allow you to push code, not containers. Okay, remember GitOps allow you to push the code not container. Git is the source of truth, describing the desired state of your entire system. Now the question is, what is a source of truth concept? So I'll put it in this way. Anything you want, declare it. Anything you want in the production environment, declare it. Now, what are the declarative language we have? So earlier XML, now not anymore. Now we have YAML or JSON. So you declare in YAML, that is a source of truth. What you want, that's a source of truth. Declare it, your desire in your YAML, put it in Git. And the moment you put it in the Git, it should be in a production. That is a concept. This is called GitOps concept. So whatever you desire, put it in the source of truth, that means file, YAML file, and it should be automatically deployed to the production. If it can be described, it can be automated with the GitOps such as apps, config, dashboard, monitoring, and etc. That means literally you can deploy literally anything using GitOps applications, configuration, dashboard, monitoring, anything. So Git without a Kubernetes, yeah. So you may have a questions like, okay, what about if you are not using Kubernetes? Can you not do the GitOps? Yeah, GitOps is not limited to Kubernetes. Okay, you can use GitOps with any system that can be observed and described declaratively. Okay, for example, Ansible is also declaratively, right? Some JSON, something like that. So currently, majority of the pull-based GitOps operator built for Kubernetes. But because we are so in line with Kubernetes, we don't talk about anything else. But it can be any code-based declarative language can be used when for the implementing the GitOps. So GitOps journey, if you look at, understand the history of it. So August 7, 2017, the term GitOps was introduced by Alexis of the Weaveworks in the operations by pull request blog. If you remember the pull request, I discussed about it. And here operations by pull request means what? That means you make a pull request for the changes in the operations in the production. That means in simple, if I say I want to deploy something in the production, I will make a pull request to you, you audit and then approve, automatically everything get deployed in the production. That is the concept. Since the blog post, GitOps has grown, seeing a buzz in the tech community online and places like KubeCon. KubeCon means Cube Conference. There have been many tools developed to support GitOps. Yes, many tools has been developed. One of the tools which I'll teach you as part of our session, but many tools has been developed. Numerous talk has been delivered, articles, blog, and even several books on the way about it. In December 10, 2020, the GitOps working group hosted its first meeting. That means it's a pretty new concept actually. First meeting as a step towards governance, documentation, guidelines, and clear definition for GitOps. So this is something which is the kind of historical reference of a GitOps process. So understanding the need for GitOps. So one of the things like, okay, use cases for GitOps is like, yes, you are on the running on the Kubernetes, which is a cloud native application. So you required you to set up a CI CD for it. CD part specifically. Okay, CD means continuous delivery. Okay, you need to also do the frequency rollout. If you understand the architecture nowadays, you see earlier we had a um, this monolithic, then we got a service, now we have a microservices. That means there's one software and thousands of services are there, and it's very difficult to manage it, right? So you need everything to be codified, that way you control better way. So infrastructure management, IX cluster, fleet, and microservices, and these are the use cases for GitOps. Kubernetes app config deployment and anti-pattern. Deployment with anti-pattern. So one of the problem with the deployment to Kubernetes is that a dev team will build an app, package it, and then hand it to ops team for deployment. This is the problem. What will happen then? Ops team will update IAC config script. IAC config script means it can be Ansible, it can be Terraform, and will use them to deploy the app to Kubernetes. This method to code in the repo is still somewhat disconnected from the live environment. So what an update to app or environment config is needed, ISE config scripts are updated and applied manually to live environment. So this is what it happens now. So this is the standard CI/CD process, the one which I have already explained it to you. We have a source code, then build environment, test environment, then operation environment. Multiple teams are there, and there is a wall between the what you do within source, build, and test versus ops. Okay, so ops, how they do deploy. So they have a QCTL apply, config map, ingress. And if you know Kubernetes, you know that little bit of it, and so on. So this is the ops team, and they deploy. So there is a wall, there is a gap. There is a gap till your product is ready and you deploy to the production. Can we fill this gap in the Kubernetes environment, CNCF product enabled environment? So look at this here. So this is the proposed GitOps pipeline. Again, it can be complicated, but again, in a simple way, you understand that. And this image is very important you to understand. So what exactly is happening here is development is committing a code, and then image is being created, which is a Docker image, and pushed to the registry. Okay, registry, a place where Docker images are located. Yesterday, if you remember, we had used a Docker hub, right? Where the lakhs of images are there. Now what will happen? CD part, okay, CD part, operators also commit. Here you see development is also writing a code, but for that software. But operators also writing a code, but for operations. If you remember my statement, which I made it in Devops, if you are doing coding for the function for the software, if you're doing coding for the testing the function of the software, or if you're coding for the CI/CD infra operations and all, then we can call it a DevOps, and that is something which you can understand here. So here operators are also, ops team also writing a code, committing a code in ops repo. And the moment the apps repo is what is happening, the image is being pulled from the registry and then deployed to the Kubernetes. Okay. Now here most important part what you have is ops repo. Ops repo and Kubernetes required some sort of sync automatically. That means the moment code is committed, automatically it should be done. See, this guy will not do any deployment sort of thing. The moment the code is committed, automatically it should happen. So here you need one ops repo you have here, and there is a Kubernetes. So and here you have images. Here you need some middleman who should keep seeing that if there is change in the code. The moment they found out the code in change, automatically it will deploy to the Kubernetes. And this part, this if you see my hovering over there, this part is called GitOps operator. Many tools has been developed for that, and that tools is doing nothing but keep checking if there is a code changes has happened in the ops repo, and the moment ops repo the changes have happened, automatically it will start deploying to the production. Are you understanding, all of you?
I think so.
Yes.
So that's the concept. So operator is somewhere some tooling system what we have, many tools we have for that. So understanding the benefit of GitOps. So let's say if you build this flow, okay, build this flow, what will happen? See this wall, the earlier we had a wall, right? It will be bridged. There's no manual activities has to be done. Automatically CD can be automated. CD means continuous deployment can be automated. So what is the benefit? So benefit, as you know, that it's all about saving time. We all are doing because of to save time. So here app and ops in Git. That means app team is also is in Git, application developer, and operations also in a Git. So that means they do both modify the code and everything runs through the code automated way. So that way you enhance the developer experience. Okay. Next one is continuous syncing, more reliability. That means the more you build the code which automatically deploy and keep any changes, small changes to keep deploying. So that way you bring the more reliability in the system and applications. That Also, it simplify the operations, increase the productivity. That means you don't need to talk to 10 people, don't need to send an email, don't need to have some approval or something. You define the GitOps process, and we know that what is has to be done, where the changes has to happen, where the PR request has to happen. You do that, you code commit, automatically it will build, automatically it will test, automatically it will create a package. Then operations also do the some changes, automatically it committed, automatically PR is approved, or the PR is approved, automatically it will sync, deploy to the production. You don't need to worry about anything at all. Earlier we used to have a lots of headache on that. Full audit control and compliance and stability. See, everything what you do, whether it's a development or operations, you do through code. So you know that who's doing what, and it's also complied, and then bring the stability. Everything as a code, because you can roll back also anytime, within a few seconds you can roll back. Consistency, that means consistency means whatever you deploy, it's across the system. Like, it's not like you deploy something here, you deploy something there. So using the code, you can manage the consistency. There's no manual work which you do that. And creating standard process, also improving the security, continuous security. So access safe security as a code, credential and state regulations, you can do that. So these are the some of the benefits of the GitOps. Understanding the difference between GitOps and DevOps. So let's understand this. DevOps, we have spent some time. What is the DevOps? You understand, a team who's doing everything. So DevOps often takes push approach, while GitOps always take a pull approach. You should understand this. See here, this image. Sync is a pulling all the time from the changes. Okay, see the image also, and then ops code also they're pulling. But DevOps is like when you commit has happened, then build has happened, test has happened, deploy. So it's like a push approach. Okay, so that way DevOps often takes a push approach, while GitOps takes a pull approach to pipeline workflow. In DevOps, the application and development pipelines are often separate, with IAC script used for static one-time deployment to the environment. Okay, IAC code means infrastructure and Terraform, whereas GitOps replaces script of kubectl, Terraform, and Helm with an operator. Mind it, here you don't use a kubectl, no Terraform. Helm with an operator that handles operations task as a create, change, delete in Kubernetes cluster based on what described in Git. That means operators will help you to do all this thing, and it will take a precedence of what you do through script. Okay, so understanding the difference between GitOps and IAC. So declarative IAC, you actually play a key role in GitOps, as GitOps syncs the state of the live environment with IAC in the code repo. Whereas declarative IAC is a part of GitOps, Terraform, Kth manifest, etc, and Helm. Okay, GitOps applies the Git ecosystem and tooling to an infrastructure. So this is the major difference between the GitOps and IAC. Now, next one is, what is the GitOps principle and practices? Okay, so if you say like, because this GitOps still evolving, because the whole CNCF environment is evolving around it. So principles probably might change in the next couple of years, because still many organizations are yet to perform this. But overall, the principle which we have decided is like, as a community, Git would be the source of truth for entire system. That means anything you want to deploy the production, testing, or anything, you have to keep the desire in the Git itself. Okay, so desire system state is versioned in the Git. That means it can be YAML, it can be JSON, it has to be version in a Git, and that is one of the second principle. System state described declaratively. Declaratively means YAML or JSON. Okay, so Git should be the use. Second one, you have to Git automatically will version this whatever you want. Third one, it should be YAML or JSON, or Git as a single place for operations, means creating the infrastructure, change or delete everything. Autonomous agent enforce desired state and alert on drift. Now, when you say autonomous agent, here you are talking about some tooling system which required you to implement the pull stuff. An automated delivery approved system state changes. Okay, so these are some of the principles of GitOps. What are the practices we do? So here we always follow the practice where pull over push. That means we sync, pull means see the code commit has happened, we pull the changes and then deploy to the production, not like a push base. At least 2 repos per applications, one for app source code and second for the config. That means this is the one of the practice you may follow, you can, depends on you. There should be 2 repos, one for application deployment, one for config deployment, so that way you can keep it a separate. So application deployment will take care of it, application team. Config deployment will take care of it, ops team. Ensure that your test, that means there should be some test environment. Once your sanity is passed in that, then you push to the basically promote to the next environment. Have a plan for secret management. I mean, many secrets you'll use, and it's not a good to hard code the secret in your file which is stored in the Git, right? Everyone can see that. So that way you can have a some secret management tool. For example, Vault, you can use it, which can be used for that, or KMS, Azure also you can use that one. So and you can have a backup. So backup in the Git automatically is done. So these are some of the Git ops practices what we have. So in summary, we have understood about the what is a GitOps. Any questions so far? Any questions so far? Hello? Okay.
No
So now,
questions.
now let's spend some time understanding the GitOps architecture and tooling system. Okay. So as part of this sessions, we'll understand the GitOps tooling, GitOps architecture, GitOps architecture and decision point, and demo will not do that today because there's one tool which we have, Argo CD, which required little bit of sessions. So yeah, today we'll finish the discussion, and the next session we'll have an Argo CD demo for that. Okay, so understanding the GitOps tooling. So look at this here. This is a very important slides. All of you must spend some time. As I said, this world is evolving, and initially there were one or two tools which got introduced initially, but now we have so many tools. Now, if you ask me, what is the most popular tools which we have here? So I would say one of the most popular tool we have in this category is Argo CD, and the same one which I'll be teaching you. Okay, but actually to be honest, this is not a complete list for GitOps. Actually, we do have so many tools left out, like cloud. I mean, this CloudBees also has introduced. In fact, every uh, company who's working on the software automation, they have developed their own tool actually for implementing the GitOps. So for implementing the GitOps, first thing which you need is Kubernetes, and that is, you know, that Kubernetes something. I don't know whether we do have a Kubernetes session or not. I need to check that, but I'll teach you the Kubernetes if it is there. So Kubernetes is the one we need it. Second one is like you need to know Docker also. And I think Docker, you know, because I think yesterday only I taught you. Third thing, we need to have some registry where you can keep the images and help. Images registry, most of the time we use this one, Docker Hub, and Helm registry is also open source, something similar where we have a Helm. Now what is a Helm package? Helm package, you can say, is like a deployment package, deployment file which can you deploy easily in the Kubernetes. Okay, so that is one. You should also know the Git, and I think you know that, just the previous session I taught you Git. You should also know GitHub, and you should know very well. Helm is the package manager which I talked about it. You need to know these are the, is like not optional. These all are mandatory. Okay, so you must know Kubernetes if you want to implement GitOps. You must know Docker. You must know a Docker registry. You must know Helm registry. You must know Git, and you must know Helm. So these are the things you must know. Apart from that, there are some tools which you need for the IAC, infrastructure coding. Which are the thing? So you need a Terraform. And if you remember, I taught you that one also. For the monitoring, you need to know Prometheus. Though monitoring, there's so many tools are there, but you know, Prometheus is also from the CNCF. That is basically well integration with Kubernetes. So I think that is a good to know. I need to check whether it's a part of our session or not. Flagger. Okay, so there is a one operator. So there is a flagger, there is a flux, there is a argo cd, and there is a Jenkins X. There are four operators which I have highlighted in these slides. Any one is sufficient. Either you learn flagger or flux or argo cd or Jenkins X. It's not Jenkins, Jenkins X. Okay, so four operators are there which will help you to implement this GitOps. Out of which one operator which I'll teach you, which is called argo cd. Okay, now you need some secret management tool also, though I will assist you, I will insist you to go for vault, HashiCorp vault, but here you have a git secret which is lightweight. Encrypt secret and store them in a git. Mind it, encrypt secret and store them in a git, automatically encrypts and decrypt in a GitOps workflow. So easy and handy tool, you can use it. Though you can also use vault. Git backup and Kube backup, there is a tool which will help you to back it up the Git. So Kubernetes and Git repos are critical, back them up. By the way, if you are on the cloud and all, so automatically it will be taken care of it. GitHub will take care of it, or Bitbucket will take care of it. You don't need to worry about it. And automate backup of the Git repos and cluster config. So these are the some of the tooling system you must know, and 4 out of 4, you should know only one. I would say go stick to Argo CD. Are you comfortable with it, all of you?
Yeah.
Time will tell.
Okay. Yeah. So guys, so yeah, these are the four. Uh, One more extra in this you have operators, very popular: Flux, Argo CD, CubeStack, Jenkins X. These are the one. By the way, there's one more which is uh, CloudBees, which is also very popular. Uh, uh, for this. By the way, I mean, almost every vendor have introduced the GitOps operator capability. So that's the thing. But these are the dedicated tool. So Flux, which is a Kubernetes GitOps operator, Argo CD, Kubernetes GitOps operated with the visual approach, KubeStack, Terraform GitOps framework for building Kubernetes on any platform, and Jenkins X. I think Jenkins, you know something. So Jenkins has community has come up with the Jenkins X, Kubernetes pipeline automation with built-in GitOps. Flux is from the fluxcd.io. I think more information you can go to their website. By the way, this is also CNCF product, supported product, by the way. So supported product, Flux. Argo CD is also CNCF supported product. I'll teach you this one. It's one of the product which you need to learn as part of the um, implementing the GitOps, and all this information you can see that. Jenkins X, I would say in all what I have experienced, like Jenkins X setting up is very complicated. I think they should work on to create a lightweight configuration, installation and configuration. But yeah, setting up is a little challenging, but this is also flawless. And look at the graph actually. Okay, number of commits and all stuff like that, and followers, tweets, and also that way you can come to know. So for example, Flux is having the star 5921, Argo has 7252, and Jenkins has 3772. That means Jenkins X is a least popular. And few more options, I just said there's so many options in the market. Okay, so what is this? So this is all about the technology. I showed you the slide actually, so I think you should. Any
I'm sorry.
questions?
Which tool you have said is the least popular? I just skipped.
Right now, Jenkins X and CubeStack also you can say is
Okay.
least popular. Most popular is Argo CD. Second one is a Flux, and these two are
Okay.
CNCF. CNCF. That's the reason it's a popular. Jenkins X is supported by CloudBees community actually. Jenkins community.
Okay.
Yeah. So most popular is Argo CD, which I'll teach you anyways. Don't need to learn everything, all tools, because this is just waste of time. Okay.
We'll
So
be
now
getting these materials as well, these PPTs.
yes, 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 yes. I'll
Okay.
share with you.
Thanks. So I will not be
Now,
taking notes from these. That's the reason.
no, no, no. Recordings and slides, you will get it. Okay, so now there is one URL. If you look at the bottom section of it, this is called radar.cncf.io. I showed you the website already, but I think you should spend good amount of time. I must insist for that, because that way you know that what are the technology they are under the graduation and under the development and many things actually. So you should spend some time for that to understand that what are the innovation which is happening. And they have created one radar kind of things where you can see this image is very small, but if you look at the website it will be good. So you see here, these are the radar. You see the trends and pattern what is happening for the CD area. No, I mean you can see the radar for many other areas, but this is for CD area. And look at the adoptions here. So adoptions like Flux and Helm, Circle Sci is also there. Um, Customize is also popular. GitLab is also popular. Many other, I mean, just said so many vendors are there, and you see Argo CD is the dominant here in this whole category. So now understanding the architecture. So you have to implement that. For that, you need to understand the architecture. So GitOps architecture components. So source control system. So I think definitely you will use Git and GitHub, at least for now, but you can use any Git and any Git hosting platform. Like you have GitHub, GitLab, Bitbucket, Gerrit, Azure, AWS commit, and whatever it is, many things. So you need to have a source control system, Git repository. You need to have your image containers. You need to have one Helm registry. You need to have one operator. You need to have a runtime environment, which is Kubernetes. Multiple environments, you may have it staging, dev, production or something, and you need to have a namespace. And now namespace you will come to know only if you know the Kubernetes. So if you know the Kubernetes, I know that you know that, but a namespace something which is related to the Kubernetes per environment, per app, per service, per engineer, per build, whatever it is. So these are the architecture. So you look at this image is wonderful. So GitHub's architecture. So I want to capture snippet of it. And here if you see this architecture, so here this is the developer, and this developers, uh, when you say it can be you DevOps guys or ops guys, whoever, no problem, they will commit to the Git, and code will be commit to GitHub, and this will be in the Git repository. It will go push to GitHub, and the now when you say this code will be your Helm chart or something like that. Sorry, my bad. This will be something like uh, yeah, Helm chart, but it can be directly. Let's say I'll put it in this way. It can be your deployment file of Kubernetes also, YAML file. Okay. So now there'll be one operators. There'll be one tool. Now this can be Argo CD, Flux, or many more, and this will be configured with your Helm registry and container registry. So container registry is like your place where your Docker image is there, and Helm registry where you have Helm charts. Okay, this will be configured. Now the moment you modify the code here, and for in order to modify the code here, you can have a PR system which I explained you. So you can have a PR script, and the moment code is approved and made in the production, I mean made in the master branch, automatically this guy will keep syncing that branch, master branch or production branch or some branch. This guy will keep syncing the branch, and the moment sync is done, this guy will apply, not you. This guy will apply for the develop environment, production environment, and so on. This is managed by Kubernetes. Very simple flow. Are you understanding, all of you?
Yes.
Yeah. So this is the way is it will work. So understanding GitOps architectural decision points, which includes, yes, Azure DevOps is one of the most popular tool which is right now under this. If you look at the implementation of DevOps, GitHub is also growing, GitLab, Bitbucket, etc. App and config separate repos. You should be having a repo per item you can create, repo per environment you should be having, or maybe see, I don't create a repo per environment, but what I do, I create a branches per environment. So that is up to you which approach you follow. Namespace also you should have a, so here in the slides you have a two namespace for two different environment, but what I have done, I have created two cluster, one dev cluster and one is production cluster. So it's up to you which approach you follow. This is again depend on you. So see that here you have a two approach. One is like either you have one cluster, two different namespace, or you have a two different clusters altogether. So I have a two different cluster altogether. That way I feel little safe, because someone, I mean, by mistake, someone should not modify my production. And then followed by these are the tools: Flux, Argo CD, kubectl, apply, Terraform, Kubernetes, and all, and sync config to the Kubernetes cluster using some commands. And also, yeah, these are the some of the decision points. Demo, which I'll show you later. Okay, so how to understand GitOps workflow? So here enabling a GitOps ISE workflow, enabling the GitOps workflow using Flux, and then a demo. So here not much, because this is just for the understanding purpose, because a demo will be done in the Argo CD. So just for the discussion sake, I'm covering. So here you have a GitOps operator types. So cloud infrastructure. So cloud infrastructure, which you can automate. So first of all, you have to create a cloud, right? Infrastructure, right? So how do you create it? So you can call Terraform for setup, upgrade, and modify using cloud, IS, IAM, Kubernetes clusters, namespace, ingress controller services, mesh, and monitoring. So everything you can create through Terraform. Once that is created, then you can deploy the package using Helm. That is something. So Kubernetes manifest, you can do that, but nowadays no one is doing. Helm chart everyone is having. And for the application deployment, power services, config map, and namespace. Okay, so GitOps ISE workflow, kubestack. This is the flow. This is a flow for the kubestack, which I'm not discussing. So I will ignore this. This is the workflow of the kubestack. This is some of the information for Jenkins X. So again, there are so many specific informations you might not need in this session, but yeah, this is some of the architecture for the Jenkins X microservices. How do you deploy and all kind of things, and so on. This is again continuous initial of Jenkins X and so on. And this is for the Flux, uh, some of the actions, which is very particular to tools actually. So you might not understand what is happening, and so this is the Flux, and done. Now career, I think,
Flex is command line based.
yeah, they have a UI wrapper also that can be done.
Okay.
Okay, so now let's say you want to discuss with your team saying that why you should go for GitOps. This is the important slides. Okay, so here single source of truth, ensure state of infra in a declarative way. What else you need? Just a one file you modify, everything has been deployed, correct? That file has, you need to control. Changes go through commit, pull request, approval before deploy. So this is something which you have to do that. This is a part of the audit logs of the changes. You should be having the rollback strategy. And in fact, in Kubernetes, rollback strategy is very easier with ability to revert, commit, pull request and all. Stability of the environment, deployment, updates, delete, all made the same way through GitOps automations. Access management, yes, is very important one. In order to perform. So CD no longer has unrestricted access to cluster and infra. That means CD means continuous delivery has a restricted access and stuff like the user access determined by Git repos access, which you can control in the GitHub, GitLab and all. Cluster access on the cluster via operators. Easier ops, yeah, no more manual changes to the cluster. Changes are specified in the code manifest file, typically we call it. manifest hosted in the Git and enacted via operators, nothing else. So everything who's doing, see, it's a advantage like who's doing, what is being done, whether it's approved changes or not approved changes. Everything is been audited and processed through Git. And once you have in Git in certain branch, it's in a production through operators, and those operators are Argo CD and stuff like that. Understood, all of you?
How the Git is different from other cloud-based the CI/CD pipeline
CI
service
is
providers?
CI is a concept, CD is a concept, but Git is a tool, right? GitHub is a tool. GitHub is a platform.
Okay, I'm talking about GitOps or Git Actions, you may say, as per se, from tools perspective. If somebody asks that, let's use a ABC tool rather
GitHub
than
action you are
GitOps.
talking about.
So,
Git.
yeah.
Oh, okay, okay, you got confused. GitOps is a concept. GitOps is not a tool. It's a concept. It's a model. It's operating.
Yes, I was talking about Git Actions, correct.
So Git action is equal to, you can say, Argo CD or Jenkins X or Flux, like that. It's a
Yeah,
CD tool.
yes.
It's a CD tool.
So we'll not be using Git Actions here, correct?
You can use it. I just said no. There are more than
No, in
20
this
tools are
training,
available.
training.
I've showed you that one already. In this training
Okay,
for GitOps, I'll show you Argo CD. But the GitHub action I showed you, right? How to create a basic one, and then the moment you make a changes in the code, automatically it'll trigger that. So you saw that,
okay.
right? Yeah. But for Argo CD, we need a Kubernetes server cluster, and then we need uh, some a Helm. I mean, this one. What is it? I forgot the name. Argo CD deployment. We need one tool. So I'll create architecture. That will be better because when I see and talk, then it's easy for me. So this is you, and this is your laptop. Okay, this is a GitHub, and here you have one branch. This is my manager. This is me. Okay, my manager. Let's say Akash. So, and this is the master branch, and this is a feature branch. Okay, now what will happen? I will commit to the feature branch, create a PR to master branch. Okay, this master branch, what you have, you put it all Helm chart. Helm chart means Kubernetes deployment file. This guy will say approved in the master branch. The moment master branch is there, there is one tool which is called Argo CD, will read immediately based on the sync what you do, immediate sync within a few seconds, and deploy this Argo CD in the Kubernetes cluster. That's all. Simple. So I need to have one cluster, Argo CD, GitHub, 2 branches minimum, this guy approval, developer, one workstation, workspace, whole thing. Did you understand now?
Yes.
So here only thing is the moment change is committed here, this guy will keep watching this source code, source path. This in our case is a Argo CD, but it can be any other tool actually for the sake of. And then it deployed to the Kubernetes cluster. Kubernetes cluster, it can be dev environment, and after that it can be production environment also. So it depends on your architecture. I was discussing that.
Have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.